This is Humble Pie, a book by Matt Parker about mathematical mistakes. It reminds us that sometimes even experienced engineers make miscalculations, especially when it comes to big numbers. 1 billion. That is a big number. It is also the amount of states a 3x3 square of tiles can be in if all of the tiles can be in 10 different states independent of each other.
I grew up in the early 2000s, and my grandparents had a PC with this really weird game on it. You randomly pressed some tiles on the screen, and if you were lucky, something really big would happen. That game was Minesweeper, and it turns out there's some logic behind it. Each number represents how many mines are directly adjacent to it. So, in essence, you have a large playing field made up of 3x3 blocks. And it doesn't matter where those blocks are, but the spatial relations within those blocks are important. That kinda reminds me of something. Yeah, that sounds about right. But just detecting things is boring, so let's make an AI that plays Minesweeper. So I made a deep Q-learning script that uses convolutional neural networks paired with replay memory, trained it for a while, and it got stuck because it tried to always open the same field over and over again. So I removed its ability to do so, and 1.12% win rate. Now, that is not great, but it is also not zero. But wait, when playing Minesweeper, you can sometimes be lucky and win by just pressing random tiles all the time. But how often does that happen? So it happens about 0.69% of the time. Now, while it's nice that our win rate is higher than that, it is really close and not at all impressive. Also, it didn't seem to improve beyond that with more training. So my next hypothesis was that it typically loses very quickly, so most of the states it sees are mostly unopened tiles. So I implemented Hindsight experience replay with a 70% chance for it to get saved from clicking a mine. So it also has some training data where a lot of tiles are open already. Which did improve the win rate significantly, but again didn't change much with more training. I also tried a fully connected neural network instead of a convolutional one, which resulted in a very impressive win rate. It somehow managed to get beaten by random chance. And this is not a cherry-picked result. This happened consistently, and I have no idea what's wrong with it. So what can we learn from this? If all you have is a hammer, then everything looks like a nail. Solving problems with deep learning, neural networks, Q-learning and so on is exciting, but that doesn't mean that you always should. There are plenty of statistical solvers for Minesweeper that play the game to perfection, so why bother? But if you want to try it yourself just to prove that it is possible to do better than this, it definitely is. The best advice I can give you is to use a convolutional neural network instead of a fully connected one, and to use Hindsight experience replay, since those two things did actually seem to help. It might have been a bit naive to assume that a CNN would be doing great at this task just because the most basic game logic is nice little squares and it kinda looks like a CNN. After all, CNNs work by having one feature map a feature they learn and then figuring out what the thing with those features is. And even though in Minesweeper the tiles depend on each other and thereby eliminate probably significantly more than half of the possible states there would be if they would be independent, there are still a lot of possible states that little squares could be in, and therefore a lot of features to be learned. Well, I hope this was informative. Thanks for watching and see you at the next useless project.
Mathematical mistakes.